Hello, this is Image Bhattrai. My teammate and I will be doing the presentation for the final project of cloud computing. I will be starting first, and then Rifat will be joining me after I'm done. Our project topic is sentiment analysis using AWS. So let me start by sharing my screen here. So my screen should be visible. As I said, our topic is sentiment analysis on AWS cloud platforms. So let's start with the overview. So in this presentation, we'll be taking a look at the introduction for our project, what exactly sentiment analysis is, what are the motivations behind this project, what the problem statements are, the data sets that we will be using, uh, the methods that we have used. We'll also be taking a look at the literature review. We'll also be taking a look at the technologies that we have used. We will be sharing our results and also the future directions for this project. And we'll also be sharing a conclusion. So let's start with the introduction. As we all know, with the growth of social media, the rise of public opinions has increased as well. Nowadays, people have a lot to say and they express their opinions and satisfaction towards a cause or a product. Understanding the sentiments of people can be useful in different scenarios such as business, politics, education, and so on. In this project, we are using sentiment analysis to analyze people's sentiment, and we will be outputting the response that we get from this project. We are utilizing AWS, and we are using Amazon SageMaker to train our models. So what exactly is a sentiment analysis? Sentiment analysis, in short, can be understood as opinion mining. Basically, it is the process of understanding the sentiment or emotion behind a cause or a text. It is useful in determining whether sentiment is positive or negative. So once we understand if the sentiment is positive or negative, we can take further actions according to what the sentiment is. So now let's take a look at the motivations behind this project. Our project aims to build a sentiment analysis tool that is going to use AWS to train models. We have used Amazon SageMaker to build our models. The results from the training and the testing of our models can be used to improve customer satisfaction because this can be used to analyze the people's sentiment. Overall, the motivations behind this project is to build a scalable, accurate model that will accurately classify people's sentiment. Let's take a look at the problem statement. In today's world, organizations need to understand the public's opinion to improve their services. However, analyzing text or feedbacks such as reviews manually takes a considerable amount of time and is also prone to human error. With this challenge, we will try to build a sentiment analyzing app that takes a piece of text and outputs a response such as positive or negative. Since this is fully automated, it takes a lot less time and is also highly accurate than doing it manually. The data sets that we will be using for this project, we are using two data sets. First is the IMDb movie data set. It contains 50,000 movie reviews, out of which 25,000 movie reviews are labeled as positive and 25,000 movie reviews are labeled as negative. We are also using SEMeval 2017 dataset, which is a Twitter dataset that contains 10,000 tweets in English. Out of these 10,000 tweets, some of them are positive, some are negative, and some are neutral. The methods that we have used in this project, we have essentially used two models, like two methods. First, we have used the traditional machine learning model, and second, we have used the deep learning model. For the traditional machine learning model, we have used naive Bayes support vector machines, SVMs, logistic regression, decision trees, and random forest. For the deep learning models, we have used recurrent neural network RNNs, long short-term memory LSTMs, bidirectional RNN, and also transformer networks. We have used all these models on both the data set. So that is the IMDb dataset and the Twitter dataset.
So hello everyone. Previously my project mate Image Patari discussed the previous topics. I will start from literature review. We have read one review paper on sentiment analysis, that is a survey on sentiment analysis methods, applications and challenges. It was published on 2022. This paper has discussed about various traditional machine learning algorithms like naive Bayes, SVM, decision tree, KNN, and various other traditional machine learning models, as well as deep learning models like RNN, LSTM, BiLSTM, and CNN transformers. And they have discussed about the advantages and disadvantages of the sentiment analysis, as well as their various aspects of it, like aspect-based sentiment analysis or multimodal sentiment analysis and transfer learning associated with sentiment analysis, etc. Also, this paper discussed with uh, this paper provides a necessary previous works like various methods, their languages, their data sets, and associated results along with it. So this paper has a broad discussion about the previous works on sentiment analysis. So our work kind of subset of this paper. The technology we have used is we have used Python programming language for the basic part, and we have used PySpark packages for pre-processing the text, and we have also used scikit-learn package to implement traditional machine learning models, and we have used TensorFlow packages for the deep learning to implement the deep learning models, and we have used AWS SageMaker to deploy our machine learning and deep learning models. Also, for some codes, we have used Colab. For example, for the transformer model, we have used Colab, as it will have fluent running on the Colab using the GPUs. And here is the results of our machine learning algorithms. We have divided our results in two parts. First is traditional machine learning algorithms. As you can see, we have deployed 5 traditional machine learning algorithms. These are naive Bayes, logistic regression, support vector machine, decision trees, and random forest. First 3 of these machine learning models are deployed by me, and rest of the 2, that is decision tree and random forest, are deployed by my project mate Image Patari. As you can see, it has kind of several mixing results and F1 scores alongside with 2 databases, that is, one is IMDb data and another is Twitter data. As you can see, for the IMDb data, we can see that naive Bayes is getting better accuracy for less number of data, and for the Twitter data, as you can see, we have got better accuracy on support vector machine. It's kind of similar results. And for deep learning models, we have used 4 different deep learning neural networks. One is RNN and LSTM network, bidirectional recurrent neural network, and the last one is transformer network. And the first 2 of these network are deployed by my project mate Image Patari, and the rest of these 2, it is bidirectional RNN and transformer networks, are deployed by me. As you can see from the results of our deployment, we have applied these algorithms both on IMDb data and Twitter data. Among these results, we can see that for IMDb dataset, transformer network is getting better accuracy, slightly better accuracy among all of these networks. And for Twitter data, as Twitter data has the least number of data, it was getting better accuracy for bidirectional recurrent neural networks. So these are the results for our deployment. Our future work involves, we would focus on various other topics of sentiment analysis, that is subtopics. For example, say aspect based sentiment analysis, using transform learning for sentiment analysis to apply the sentiment analysis for other tasks like named entity recognitions of natural language processing, multimodal sentiment analysis, etc. And we would also explore other techniques apart from the traditional machine learning models. For example, say we would apply some novel ideas associated with sentiment analysis. And here is a conclusion, that is, we have open sourced our code on a GitHub repository. As you can see, I have given the link here. If you have any question about the code, you can email me. So these codes are all open sourced, and thank you. That's all for me. If you have any question and comments about regarding the results and the codes of our project, you can email me or Image Factory. And thank you very much.